Hello everybody, this is Dr. Morales, and in this video we are going to classify numbers as rational or irrational. Before we get started, let's talk about what rational numbers are. A rational number is any number that can be converted into a fraction. Any number. If you can make it into a fraction, then it's a rational number. And we'll talk about how to change a number into a fraction. We're going to talk about that as we work out this problem. Now, on the other hand, irrational numbers are the opposite. These numbers you cannot convert into a fraction. So, as I said, those are the opposite. Now, just to have an idea, an irrational number is a number, because it cannot be converted into a fraction, for the most part, these are decimals that do not terminate, that means they don't stop, and do not repeat. So these are decimals that keep going on forever and ever, but the digits don't have a pattern, they do not repeat. Okay, and that's why I put this number, which is the number pi, I put that into the irrational numbers position. This number, when calculated, it keeps going on forever without repeating and without terminating. So this is the number pi. Now the next number is -1. Now -1 is an integer, and an integer can be converted into a fraction by putting a 1 under. So -1 is the same as -1 over 1, and that makes it into a fraction. Therefore, -1 is rational. So all the integers are rational numbers. Remember, integers are whole numbers and they're opposite. So whole numbers 1, 2, 3, 4, opposite -1, -2, -3, -4. Now the next one is pi times -1. Now I know you see the pi, and pi is an irrational number, and you see the -1, and -1 is a rational number, and we also see a multiplication symbol. Now think about this, okay? When you multiply a number times another number, usually my product is a bigger number. Now in this case, we have 3.1415 going on forever multiplied by a -1. So the -1 is going to be my answer negative. So it's going to be negative 3.1415 on forever. And by 1 is the same number. So this repeating decimal still stays repeating decimal. The only thing that changes is becomes a negative not repeating, but not ending, not terminating decimal. Therefore, this number is still an irrational number. Let's submit the answer, and our answer is correct. Now let's go into the next group. So now we have the number -2 is an integer. Remember, any integer is a rational number because we just put a 1 under. Then we have the number 3, which is also an integer. Remember, whole numbers in the opposite. Put a 1 under, that makes it 3 over 1. It's a fraction, so therefore it's rational. And now we have -2 plus 3. Now -2 plus 3, if you still do not know how to add integers, you have 2 negatives and you have 3 positives. So opposites cancel each other, so we cancel 2 from each and we end up with +1. Therefore, this is also a rational number. So in this group, there are no irrational, there's non-irrational numbers in the group. So let's submit, and that was correct. So let's go to the next group. Okay, so we have -1, which is an integer. We have the number pi, which is an irrational number. And once again, -1 times pi is an irrational number. Let's check, and my answer is correct. Move on to the next one. 6 is a whole number. It's rational. Whole number, rational. 6 plus 1 is 7, which is a whole number. Therefore, it is a rational number. I'm going to submit, and my answer is correct. Okay, so 3 is a whole number. 9 is a whole number. 3 plus 9 is 10, 11, 12, a whole number. Therefore, those are rational numbers. Okay, last one. We have -4 is an integer. It's a rational number. pi is an irrational number, -4 plus pi. Okay, so the -4 plus the pi. Now remember, pi is 3.1415 and it keeps going on. To that, if we subtract -4, it's going to give me a -1. However, that decimal piece, that doesn't get eliminated, so that stays there. So what this is going to be is -1 0.1415, and it keeps going on forever without repeating or terminating. Therefore, this is also an irrational number. And that will be our last question for today. And that's how you solve classify numbers as rational or irrational.